Hey everyone, Chris Chatto with ZGF, and I'm going to talk about our concrete tool, and then Jake will follow up with Upstream about sustainable sourcing of wood. So let me share my screen here. So our concrete tool, we've had this for, I don't know, 5 years or so. So it's an older tool. It's certainly now with more concrete suppliers like in Seattle having their own EPDs, it's less critical. But I'm going to show you an example actually for Seattle project where we still used it. And we are using this tool still in locations across the US where suppliers don't yet have EPDs. And I have a feeling you can see my screen, yes? Okay, so just to point out, so the tool is really taking data from two different sources. It's using Tally as well, and we started using this tool. We would analyze concrete mixes for a project in Tally. Like Melanie was talking about, it was a little time consuming sometimes to plug that information in, and analyze specific mixes and then isolate that component from a model. And we're like, hey, let's just get the information out of Tally. So Roderick and Kieran Timberlake, back when they owned Tally, told us we broke the licensing agreement by pulling out all the raw data from Tally, but they liked what we did. They gave us permission to use the data. And what Tally is really doing is taking your component mixes, the components of concrete, the cement, the aggregate, et cetera, using their GABI North American database and doing an LCA on those components. And what our tool does is that for a baseline, it compares it to published NRMCA regional mixes. So it says in the Pacific Northwest, 4,000 PSI concrete has X pounds of cement, X pounds of slag, et cetera. So it's comparing to an industry average baseline. This is version 4.0. I do want to let this group know that actually in the coming weeks, we'll be releasing version 5.0, which will have NRMCA 2022 data. It'll also have additional functionality, including Portland limestone cement, which we're seeing in many markets, including, I think it's pretty ubiquitous in Seattle. Allow you to introduce any other custom ingredients if you have some LCA data, if you're using ground glass, pozzolan, or et cetera, and a few enhanced options for output. But let me just quickly show you how this tool works. So basically, you do this for any one project, you pick your region, right? So these are based on those NRMCA regional mixes. So this project I'm showing you is in Seattle, so we're saying Pacific Northwest mix. Comparing against the most recent baseline, I've actually, when I've looked at 2022 NRMCA, it doesn't vary dramatically, but again, we'll be updating that. And then cradle to gate or cradle to grave. So, if you're using this for a lead analysis, and the nice thing about using this to predict for lead is we're using this with Tally, so it should be aligned. You can pick cradle to grave, or if you're comparing against other EPDs or et cetera, we'll use cradle to gate. One thing this does is it actually takes that NRMCA data, formats it in a table. So we use this sometimes with suppliers and contractors early on to say, okay, well, yeah, we're targeting low carbon mixes. So you may not have EPDs yet or at all, but you could say, well, for a 4,000 PSI mix, we're looking for less than 500 pounds of cement per cubic yard. And we know if we're under that number, given that cement's the big driver for GWP and concrete, we're in a good state. And then if you have any other mixes, like if they're in between or you have extremely strong concrete, you can kind of interpolate, extrapolate data, which we've seen is fairly accurate too. If you have those odd strengths, and you can put them there, and then the tool will calculate for you. So coming over here now, so this is where you would input your mix data. And so what I have on the screen is submittal from Stoneway. I blacked out the project, but I'll give Stoneway credit because these are some, I was really impressed by the GWP reductions for the mixes they submitted. So what we're doing is just, mix by mix, just keep track of what the name is, what the design strength is here, 6,000 K, 6,000 PSI. And right now I don't have quantities, so I'm just going to put in 1 cubic yard and then literally input the mixes. This is actually type 1L, as I was saying. So we've been hacking that a little bit, but I'm just going to enter it as if it's regular cement. It's, about 10% better. And a high content of slag, actually equal slag, coarse aggregate is my 1,927 pounds, lightweight aggregate or sand, 1298 no lightweight, and then 250 pounds of water. And if you have rebar and you want to compare to rebar, you can too, or you can just compare the mix. So entering those, just those set of numbers. This is the NRMCA benchmark, because you can see already it's like it got twice as much cement, has a little bit of fly ash and a tiny bit of slag. So we know we're going to look good. And then if I gotta move this. So if we look over, this mix is about 48% better using this methodology. Again, like if you compare to like their EPD against in our MCA EPD, I bet it will be within 5%. And I've actually entered multiple mixes here for the entire project. Again, 1 cubic yard of each. And then the overall reduction for all the mixes that have been input in the spreadsheet is here. So a 40% reduction in GWP. And since I did this for this project, I got the quantities from the contractor, so we dialed this in a little bit more. Actually, ended up closer to 50%. And then we do have a couple charts here showing the reduction are proposed against a baseline. And again, the new version will have, you'll get to see the contribution of each individual mix. And you also, just FYI, will actually report the NRMCA industry EPD global warming potential in addition to the one that we calculate with Tally. So super fast, super easy. And the project I did this with Seattle, the Stoneway is producing EPDs. They didn't supply EPDs with their first submittal. So we wanted to check just to see, hey, did these look good or not? And so use the tool in that case. Pretty confident these are, one of these was 80% cement replacement, which is highest I've seen. So this is a good way to check, good way to compare. And we've used this in projects where, maybe weather conditions changed, and the day before the concrete contractor saying, hey, we're going to come in with a different mix, and able to kind of really kind of dial in and make sure it still meets our environmental performance targets. So that's that. I'll put in the link where you can download this, and if you do that and register with your email, when version 5 comes out, we will send that to everyone who's on our list. And I think with that, I'll turn it over to Jake.
All right, from concrete to wood, go ahead and share my screen. Share. All right, upstream. There we go. All right, so upstream forestry carbon and LCA tool, another kind of material specific analysis piece. This is just the team that put this together. Lots of countless hours from ZGF, me and Marty, and also Chris and other folks from our PPT group, and also the University of Washington cohort, which was a partnership with the Applied Research Consortium program that took this to kind of the level that we did with our first sort of public launch. We call it upstream, but we really should call it upstream and downstream, right? Like the kind of two focal areas for looking at more advanced wood LC parameters would be trying to take into account the forest and the kind of carbon dynamics on the landscape, connecting it to wood procurement and products, and what does that even mean? And then also looking at downstream impacts of biogenic carbon assumptions, end of life scenarios, and data sets of just like what is the range of outcomes based upon getting a little bit more advanced around our different data assumptions. That's the kind of scope of the tool. It is, if I click forward here, there we go. Just a spreadsheet. I've got FOMO in terms of how slick some of these other tools are in terms of their kind of online databases. Maybe we'll get there someday, but right now it's just spreadsheet. These are all the different modules that we build into it and all the different sort of clickable green input values. So this sort of shows how simple the tool is, but there's a lot of different data and assumptions and power that you can do behind it. The outputs I think are really interesting too, in terms of, part of our goal is to try to increase the legibility of wood LCA. So really kind of breaking apart the different modules and understanding the GWP impacts, across this, even splitting it between biogenic and fossil-based end-of-life emissions becomes really important as we start to think about, how this plays out over time. But even just sort of separating A1 through A3 and the biogenic carbon in the product can be useful too when we're starting to look at different assumptions. So just the way that the data is shown, I think, is really important. And then in terms of, getting to those two different scopes, the upstream portion is sort of still in kind of a proof of concept phase, right? We've been trying to leverage the eco-trust research around connecting carbon stock change factors via satellite imagery or simulated certification values, connecting it to wood procurement and trying to, come up with a factor that can be used for forestry. If you want to learn more about this process, I've included some of the links, right? There's a technical advisory committee that is trying to publish these values and sort of QA/QC them. So like using these factors comes with a grain of salt. It's not a verified process, but it is at least allowing us to kind of input a number and start to understand, well, what is that range of impacts if we source from these different types of landowners, and what is the distribution associated with that? So in the tool under the sort of module 7, you can actually input from this map, which is interactive, these different kind of woodsheds and understand what that means for the overall LCA. Like I said, still pretty proof of concept and hard to make any confident claims about that now, but it does start to give us some insight into the role of the forest. And that will continue to advance, although that's been much slower than I think we had originally planned in terms of having the research get to a point where we can incorporate it regularly into LCA. The downstream portion is interesting in terms of really trying to understand the impact of different biogenic carbon scenarios in terms of its end of life. And what we found, with sort of some of the typical ones out there, whether it's net neutral or looking at, Appendix B and the EPDs according to PCR or Tally's assumption, right? They're sort of all over the place, which sort of behooves us to be more intentional in sort of understanding what that range of outcomes could be. So at least in the tool, you can kind of cycle through these to understand that sensitivity. We built into some factors to where you can actually input your own end of life scenarios, and you can switch between the EPA warm assumptions that Tally uses, and then also sort of the custom or stock EPA warm assumptions to be able to build your own scenarios. We built this, and then we were like, well, what numbers do we put in here, right? That was sort of the next question. So part of our ARC version 2 research sort of focused on this amongst other questions. There's not enough time to really go into everything, but once we started to dig into some of the local municipal data for Seattle and King County, we found that it was all over the place, right? So this just sort of also suggests that we should be understanding our local markets, maybe sort of refining our assumptions from the 2014 or 2018 national average, maybe looking at what that might mean locally, or at least understanding what if it's primarily landfill, which are sort of our typical assumptions, versus primarily incineration, which is what we're seeing with most of the municipal data that's out there. We also devised a base study where we looked at designing for disassembly. We got a bunch of structural engineers and demo contractors together to look at these different bay designs and try to come up with, well, what would you have to do to make this recoverable? How much of this CLT do you think we could recover if it was this kind of composite action connection versus if it was able to be removed, to try to give us some sense into like what might you put into the tool and what's the overall outcome. Just focusing on Bay 1 and Bay 2, where the slab isn't connected to CLT, like what if we could recover that? Question 1 is like, does it even matter, right? Like how much do you actually save? We created all the different scenarios based upon Tally, what we saw happening with the municipal data, and then what if you could recover most of that, those different pieces based upon the bay type. And all said and done, right, sort of looking at it from an entire assembly standpoint, between a composite CLT versus a broken CLT and composite slab, we're finding overall compared to a steel baseline for a bay, right, 8% absolute percentage difference when we're looking at reductions from a baseline, or an 18% difference when just looking at those two scenarios. So your first look into, does this make a big difference or a small difference? It's substantial in terms of even these numbers, right? They're sub 20, but it can make a difference across the overall LCA. If we zoom into just the component in terms of CLT itself, then we're actually seeing a 46% difference in terms of being able to recover 75% of that CLT versus using those standard assumptions that we see in the LCA. So enough of this to kind of continue to say this is important, like our decisions and our intentionality could matter. So it's something we should continue to get smarter about in terms of analyzing this in the future. So to leave you all with a couple of links, we were selected by Metropolis as one of the responsible disruptors. We did a podcast with them. It's like a 45-minute podcast talking about what LCA on the Deep Green podcast. There's a link to that, and then a link to our GitHub site where you can download the first version of the tool. We're going to try to incorporate all of the 2.0 RC research in sort of the next release of the tool, which we were hoping to be sometime this year. We'll see if we can get around to it. But on that website is the documentation and a bunch of YouTube walkthroughs of me going through the tool, since we didn't do a live demo here, but you can watch those videos if you want that as well. And then also, if you're interested in reading more about the kind of blast through of this design for disassembly study, we'll include a link to download this research board, which we showed at the Mass Timber Conference a couple of weeks ago. So bonus, you get some of our transparency research, but the bottom half is the designing for disassembly study.